As we get into topic 8 now, the last section of chapter 2, we're looking at function operations and composition. We'll deal a little bit with arithmetic operations on functions, the difference quotient. Now remember, this word quotient refers to a fraction, and then we'll do this part toward the end, composition of functions and domain. Looking at this first paragraph, we talk about the arithmetic operations on functions. Now, this is something we've done in the past, and you could look it over. The things to pick out are there is your revenue function, and there is your cost function. Now let's analyze this just a little bit. This is what you're going to sell each item for, and this X stands for the number of items that you're selling. So in a sense, this is the slope of the X value here. And then manufacturing costs, fixed costs, are this. And to produce each DVD is $118. And again, that's the number that you're going to sell, or produce in this case. So this would be your cost function. This is your revenue function. Now, these are linear equations, so they produce a straight line graph. And as you look at the revenue, what is your y-intercept? Well, you might say there's nothing out here. So this indicates your y-intercept is going to be at 0. So this red line is for your revenue. Now, as you look at this one, this has a y-intercept, and then that is shown right down here on your y-axis. So the blue line is your cost. Now, right here, you see the lines intersect. So above this line, that's when you start making a profit. And they're asking us to look at profit, which we looked at before. Your profit function is your revenue function minus your cost function. And we're producing 30,000, and we're going to knock off these last 3 zeros and just use the 30 part. Okay, so if you put the 30 into this formula here, you get this, and this formula here, you get this, and when you subtract it, you get this. So this indicates that the profit from the sale, right in here, of $30,000 gives you $700,000 in profit. Now, one of the things I recall, because I did the study plan on all these units, is that you have to be careful whether you're going to put in 700 as a number or 700,000 as a number. Be careful what they say when you answer the problem as to which one they mean, so you don't put it in there incorrectly. So actually this is something we've done already, if you recall, back in section 4. Let's go on. Now in this next section, what they're asking is to become familiar with the operations. Now in arithmetic, we have addition, we have subtraction, we have multiplication, we have division. These are our 4 major operations. Well, they're then applying these to function notation. So here, as is indicated, this would be addition. So whatever your x values are in the function you're dealing with, you're going to add them. This is a sum. This would be the symbols used to indicate subtraction. And now, since there is no sign between them, this indicates multiplication, which is a product. And in a sense, these are considered factors. Now here in this fraction form, this is considered a quotient. So you're going to take the f function divided by the g function. And they are giving this qualifier that your denominator cannot be equal to 0, because that would make it undefined. So the domains of all of these would include all real numbers. In the intersection of domains, while in this one, where g would exclude any value in its domain, that would make our denominator a 0. So again, this is not new. This is something we've treated a number of times in past lessons. So again, this looks pretty straightforward. Depending on the signs of the functions, these are the arithmetic, sometimes pronounced arithmetic, but you have your choice. Okay, let's go on and take a look at this one. So what we're doing here, here's our f function, and there's our g function. And what they've asked us to do is to evaluate what our f function will be when we put a 1 in there, and our g function when we put a 1 in there, and then add them together. So here we're going to put the 1 where the x squared is. 1 squared is 1. 1 plus 1 is 2. So we have a 2 then coming out of this. 3 times 1 is 3, plus 5 is 8. And now we add the 2 and the 8 together, and we get a 10. So again, as long as you understand what's going on here, they're giving you the value to substitute for the x. You calculate this, calculate that, add them together. Now we need to go up a little bit to see our next thing. And get a little room, hopefully. There we go. Now in the next one, again, they're defining the operation, it's subtraction, but now we're going to put a -3 where the x is. So -3 times -3 is 9. 9 plus 1 is 10. Then we put a -3 there. That's going to be a -9. Plus 5 is a -4. Now here you have to be very careful because your g function is a -4. But what are they asking here? They're asking you to subtract them. So there's this subtraction operation right there. Now, when you see this and you're using arithmetic, what is the opposite of a negative? Well, a -1 times a -4, again, will make this a positive. And that gives you, for item B, 14. And here they're showing you to multiply, where we're going to put a 5 in there. Well, 5 squared is 25 plus 1 is 26, which we can just see on the bottom there. And then a 5 in there. 3 times 5 is 15, plus 5 is 20. So these are our values after we do the substitution, and then they've asked us to multiply our functions, which we do here, and I believe the answer is down below. All right, let's do G, or letter D, I should say, first, where we have a quotient we're going to divide. Now, if we put a 0 where the x squared is, that becomes a 0. So our numerator is going to be a 1. If we put a 0 here, 3 times 0 is 0, our denominator just becomes a 5. So this answer will be 1/5. And I'll have to raise it up here a little. And this answer is 5/20. So again, as background, as you go to do your practice and later your Quizmes, you know what they're asking you to do here. Now in example 2, again we're defining our f function as this and our g function as this. And we are asked again to add them, subtract them, multiply them, divide them. And they also are asking you to define the domain. So we could just look at this here and check it out. So here in letter A, we're going to substitute an x for our value wherever we find the x above. Now, this is a little tricky, and it's good that they show us the example, because what are they defining as x? Well, they're saying this whole thing here is our x. So we're going to take our x, which is this, and put it there, plus what are they defining here as our x? Again, all of this. So it's the combination of just these two things is our answer. Now you might say, can you simplify this anymore? And the answer is no, because there are no like terms. This is a term, this is a term, this is a term, and there are no like terms. Now, for this one, since we've seen now what they are defining as x, which are just these up here, when we subtract them, we're going to put this, and then put our negative sign to indicate subtraction, and then we put our g function. So this is b. Now, how do we indicate multiplication? Well, we put a parenthesis around this and no sign between them. This indicates multiplication. And then for letter D, again, since it's x, we're just going to put this over this to indicate our division. Now, as we define our domain of these, now in all of these, since we have a radical, as we go to look to the domain, remember under this radical sign, you cannot have a negative value. So we remove the radical sign and say, what is greater or equal to 0? And when we solve this, we get that x has to be greater or equal to 1/2. So this pretty much defines everything that we're going to do in our domain here. So let's take a look at it. Now for the f function, by the way, since this is just this, there are no restrictions. So for this part, your f function, that would be from negative infinity to positive infinity. But then we're having an intersection, which is a symbol you may or may not have had, which looks like so. And then you say it goes from 1/2, where 1/2 is included in the set, to positive infinity. Now, whenever you have an intersection that's shown like this, it's the part that both parts are included. So if we made a number line, and we darkened everything in here, that would be all real numbers is what this one is, the f function. This is the domain of the g function. We now look for the part that it overlaps. And this is going to start here. This is 1 at 1/2 and goes like so. So the domain of all of these basically will be this right here. And again, that's because of the radical sign. And again, you can look carefully. Well, I'm going to take one little step back in that the one where we have addition, subtraction, and multiplication, it is 0 is included in that set. So therefore the 1/2 is included. But where we are dividing and your denominator cannot be 0, it's excluded from the denominator. Here we have to put a parenthesis. So one clear difference. Here it's 1/2 is included in the first three: addition, subtraction, multiplication. 0 is okay. But when it's in a denominator, you cannot start with 0 because 0 is excluded, which is what they're showing. And it would start with a parenthesis. I stand corrected. All right. Let's go on to example 3. Now, in example 3, we're going to take a look at this graph, which is a graphical representation of the function. This is the one for f. This is the one for g. Now, if you made the graph of these, the blue line is for the function of f. The red line, you recall, is that square root function. And now, looking at the graph, you want to see if you can pick out various values for what they're giving you up here. Here they're saying that x is 4, and it's the sum of these. So again, our 4 is x. So we go down to our x-axis. 1, 2, 3, 4. And now we go up to our line here, and this coincides with 9. 4, 9. Very good. Now we're going to look for our g function. We go over here to 4, and we go up to 2, and then that is correct. Okay? Now, let's look at... Now, if you have your book, of course, you can just go ahead. We have to move to the next slide. And when we add our f function to our g function, we get the results 11. All right, let's go back. Now, for this next one, we're going to do a -2. So where is x -2? Well, it's -2 right over there. And we go down, and it looks like it's going to be a -3. So -3. Now we go to our g function, a -2. Well, notice -2 is not a valid example of what we would have because the numbers stop at 0. So here they're saying that part is undefined. So we have a -3 and undefined. So we're saying for the arithmetic function of f and g, of subtraction, where we include a -2, we get a -3 and undefined. So therefore, this function will be undefined. Going back to the... Now we're looking at multiplication of 1. So where x is 1, this will be 3. 1, 3. And where this is 1, this is 1. 1. That's an easy one then. 3 times 1 is 3. All right, now let's look at division here. So it's going to be 0. Well, if this is 0, it looks like our y result is a 1. When x is 0, y is 1. X is 0, y is 1. And then when we have g is 0, it is 0. Now, when we divide our f function by the g function, we get 1 divided by 0. And what did we say that was? That is undefined. So we now can go to the next page and see what we've just done here. And we've just said that. Okay. And they repeated some of the material for us there. All right, we're now going to look at what is called the difference quotient. Looking at the diagram they're giving us here, we see point P right there and point Q. Well, putting these numbers in a sense, we can find the slope of this line, and m is slope, results in this formula. And it shows the derivation of it here. This is called the difference quotient. We're going to use that on our next page here. Finding the difference quotient. So there's a formula, and there's our function. So to solve this, we're going to use what they show here, because it gets kind of tedious should I try to write it out over there. Find the first term in the numerator and replace the x, this x, with x plus h. So this x up here is replaced with x plus h. Now this then becomes a binomial that will later square. And then this x again with x plus h. So we distribute, we square this, we combine like terms. Wow, lots of stuff going on. And then we end up with this. We then put this over letter H. Notice that the H's will, once we factor the H out of there, the H's cancel out, and we end up with this. Now I recall when I did this example for my QuizMe, it was quite tedious, and it took quite a while. Now, an interesting thing that we're seeing, I meant to say this before, they talk about section R2, R4, R5. What are these? Well, these are all sections of a chapter called R, which is a review chapter, which we don't cover in Math 1110. But it is in your textbook if you want to go back and look things up as reference. This, supposedly, you're bringing these skills into this course. And they do give you a caution that if I took the time to go over it all, would take too much time. All right. So we're going on now. And again, this course is to help you prepare for calculus. So they give you this sidebar here where they go over some of the things of how this will be useful in your next course. But we're going now to, I believe, our last topic, composition of function and domain. Now, composition in general means this. Now, in a very simple way, you're inputting something into a machine. You get an outcome. You take that outcome, put it into the next machine, and then this gives you your n item. And here's how they're showing it, which is much more detailed than my example. You have input X, goes into this machine, you get an output. Then you take this output, put it into this machine, and you get this. And this is the way they write it. Okay? Now, there's other ways to write it too. I have seen it written this way, that you have your f function, and you put like a little circle there with your g function. Or they'll sometimes put it in parentheses, f of g. Looks like fog, but that's just actually a little circle, which is defined as f composed with g. So this is what they're saying. So part of what we're going to be doing here is to understand what this is all about. And here it is right here. Didn't have to wait too long. So the function with y values that looks like this is called the composition of the function g with f. Now here they've switched it around. The one I had shown on the previous page was f of g. But now they switched it around, which is okay and will happen, g of f. And all it means is instead of putting the f value in first, you're going to, well, here you're going to put the f value in first and get the g. The other one was you put the g value in first and get the f. All right, but let's take a look at an example here. Otherwise it gets kind of complicated. And we all know about genes, so let's take a look at this example here. So here we have a pair of genes. Looks like a tooth. But anyway, the manufacturer is going to put these on sale for 25% off. So they were 100. Now they're going to be 75. So after your initial computation, you get a 75. And then at the register, you have a coupon which says you can have an additional 10% off. So you're going to get another 10% off. So that will be minus 750. And then that is your final output. So you get an initial, take that value, put it into the next machine, which is a 10% off, and then that gives you your end price. Okay? So, let's say you get 35% off, but it's not quite 35% because it's gone down initially by 25%. So it's not quite 35%. Keep in mind, that is not correct up here. And the way we said it was correct. All right, let's look at some examples. Okay, and here there looks a little complicated, but it's just showing you what we've done. So let's use our $100 one here. So this is the $100. You got 25% off. You now have $75. Now, this was 25% off. Let's see. Now, you're going to get 10% off of the 75. So it's not the sum of 25 and 10, because these are different functions now. Here it's 25 of 100. It's 10% of 75. So using these figures, you see this is your correct end price. All right, so now let's take a look at the real kind of examples they give us, or the algebra. Now, understanding what the original problem is really crucial to this. But hopefully we've put you step by step to get results. So here's your f function. And there's your g function. And they're asking you to find f composed of g. So we have to find out what will be the results of our g function when we put 2 into it. So there's our 2. We're going to replace the x with 2. 2 minus 1 is 1. So we get 4 over 1, which is 4. So using this in our g function, we get a 4. We now take the 4 and put it into our f function, which is 2 times 4 is 8. 8 minus 1. 2 times 4 is 8 minus 1. Our end result is 7. So again, looking at what they're asking, they're saying take this 2, put it into your g function, get a result. Then you're going to take this value and put it into your f function, and then that is the answer. Not too bad. Now, we lost the original example, but the difference here is that they want you to now have g composed with f. So what you are doing here is first putting this -3 into your f function. Once you do that, you then take that value, put that into your g function, and it ends up as 4 over -8, or a -1/2. Now again, in MATLAB, it's crucial that you do the simplification. Leaving it as this, they're going to count it wrong. Unless they say don't simplify. They always want you to simplify. Okay, let's go on. Now, as we go on to example 6, they want us to determine the composite function, which we should have a little bit of a handle on already, and their domain. Now, once again, as soon as you see something in its radical form, x has to be greater or equal to 0. So that's going to restrict any negative values being in the domain. And since we are just doing multiplication here, there's not going to be any concern that our denominator will be 0. So 0 will always be included. And you can follow through. First, they're asking us to do f composed with g, and then reversing it, g composed with f. And they show you the solution here, that x will be greater or equal to a -1/2. And when we put that into interval notation, it looks like this. And I'm not going to go through all of it. You can look at that yourselves. I wanted to be sure you knew how to do it. And then reversing it. Again, your domain 0 can be included because it's in the numerator. Now, when we look at example 7 here, and we see that we have values of x in our denominator, here we see that x cannot be a positive 3. And here we see that x cannot be a 0. And we're just, instead of using a number, the generalized x in here. And it is worked out in some detail for you. And a new thing that they're showing us is the union symbol, that it will go up to 3, but not including 3, and then starting at the other side of 3 and going to positive infinity. And here, again, rather tedious. The tape is already 40 minutes. A lot of stuff in this particular section. And again, we'll let you look at this. I'm not going to try to do everything because it will make it too long. And these are critical. And again, you're going to have to study it, but at least you know what they're asking and some of the basics in there.